Good morning, everybody. Getting my pen color here all set. Now, today we will be continuing on with our negative exponents. But remember, you still need to know all of your previous properties and rules dealing with exponents. So what I would love for you to do is take out your calculator and any of your other notes you have out, and we're just going to do some problems to make sure you can get all of this done. So first things for number 1, do you see when it says simplify? All it means is reduce. So if you notice what I just drew in, 14 over 49, before we take care of that squared, can we reduce 14 over 49? I can divide by 7 and make that a 2, and divide by 7 and make that a 7. So before I'm distributing in this power of 2 here, it just makes things a little easier. Okay, so you can almost think about it as 2 over 7. Now, for the variables, x to the power of 34 over x to the power of 36, I look and see where is my bigger exponent, and I realize it's in the denominator or the bottom of the fraction, and I subtract. I do the same thing for my y's. 100 is bigger than 99, and I subtract. And for z's, 46 is bigger than 40, so it'll go on top, and subtract. Now, there's still in parentheses to that power of 2. So now distribute 2 to the top becomes 2 squared, which is 4. 2 here to the z to the power of 6 becomes z to the power of 12. Now it also goes to the bottom or denominator of the fraction, 7 to the power of 2, or 7 squared is 49. Okay, x squared to the power of 2 becomes x to the power of 4, and y to the power of 1. Now, again, this 2 here gets distributed, becomes y squared. And just double check, is there any variables on the top and the bottom that I should be subtracting? Is 4 and 49 reducible? It's not, so this would be my answer. Okay, so far so good. Now we can't do that same thing for number 2 because only the top or the numerator of the fraction has the parentheses around it. So really what you're going to do is, I'm going to just move this down for a bit. And I'm just going to move this down for a bit to give myself a little more space. Oops, we'll just leave that there. Okay, so distribute this 3 into here. So now that becomes 4. Now, if you get confused, you can always put those 1s here in case you forget that that's really something to the power of 1. So when I distribute, I'm going to work on that over here. So that becomes 4 to the power of 3, a to the power of 12, b to the power of 3, all over. And now the denominator stays the same, 8, a to the 12th, b, and I like to write that first just to make sure I know what I'm doing and I don't lose it. Now I take my calculator out, or I just think what's 4 times 4 times 4? This becomes 64 on the top over 8 on the bottom. Do you see we have an a to the power of 12, a to the power of 12? So that's the same exact thing on the top and the bottom, so those cancel out to 1. And b to the third over b to the first becomes b squared. Now, simplify what is 84 or 64 over 8. That just becomes 8, and the b squared is still there. So that whole thing for number 2 becomes just 8b squared. Okay, now for number 3, this becomes a little long, okay? These would be good warm-ups for you to try. So I'm just going to write, this first part stays. So we have negative c to the 4th, that's a 4, d to the 1st, e to the 8th. Then we have a negative c, power to a power, negative 4, d 6, e 2. Okay, now remember, we want to keep those exponents happy. So all I'm going to do, if I see a negative exponent, I could move it to the bottom of the fraction. But what I could also do is add across if I want. So if I look at c's, please note this is like a negative 1c versus a c to the power of negative 4. That becomes a little different. But if I want to keep that negative c to the 4th, d to the 1st, e to the 8th, now notice I have a negative c. I'm making this exponent happy, so I'm putting it in the other part of the fraction, which is the denominator, d to the 6th, e squared. That's if we like to keep them happy. Okay, now be careful. This here means negative c times negative c times negative c times negative c. That is just c. Remember, it's an even exponent, so that becomes c to the power of 4. This is really negative 1 if you thought about that. So those in effect cancel. So we have that negative brought down. Now think d to the 1st, d to the 6th becomes d to the 7th. And now that's e to the 8 plus 2 is 10. So that's what that would all become. You just got to take your time. Okay, now number 4, look at number 4. This becomes awesome fun because both of these negatives are out front of the number, but they are not, there's not parentheses, so it's not negative 4 times negative 4 times negative 4 six times, or for 3 times on the bottom. That just really represents a negative over a negative, which is a positive. And now they're the same coefficient or base, sorry, they're the same base, different exponents. So just subtract. That becomes 4 to the power of 3. But again, I don't leave it like that. Now I do the math, and I know that is 64. Okay? And number 5, almost too easy. X to the 7th and x to the 7th. Whenever we have the same thing on the top and the bottom of a fraction, it cancels. And remember, it cancels out to 1. Okay. See if you have any questions. If not, we're going on. So just a reminder, you're saying, can you simplify expressions with negative exponents, as we did yesterday? Can you apply the properties we used yesterday? And can we explain what anything to the power of 0 is equal to? So again, what is the meaning of a negative exponent? Well, in effect, 2 to the power 4 means 2 times 2 times 2 times 2. That is in effect 16. This means I'm taking 2 times itself 3 times, which is 8. This is 2 times 2, which is 4. Oh, do you see what's happening? 2 to the power of 1 just means you only have a 2. Anything to the power of 0 is almost too tricky, but anything at all, a number or variables, gives you 1. Now, do you see it's going 16, 8, 4, 2, 1? Do you see the pattern? Do you see what's happening? We're really taking this. Now, and you might want to even check this in your calculator. If you take 2 to the power of -1, what does it get? But that means 2 to the power of -1 really means 2 to the power of -1 over 1. But to make this top, this numerator happy, I have to move it to the bottom of the fraction. Now that makes that exponent 1, and you can't leave the numerator blank. So 2 to the power of -1 is really 1/2. Do you see? And we want to keep those as fractions. We don't want to use our decimals. Now, think what 2 to the power of -2 would be. I know it's kind of getting cut off, so I'll write it over here. 2 to the power of -2 is really like saying that whole thing over 1. Move it, make that a happy exponent, so we put it in the denominator. We can't have a blank numerator. Now do the math and leave it as a fraction. Do you see what's happening between 16 and 8 and 4 and 2? That all has to do with that base number. Okay, now simplify. No negative exponents are allowed. So here's what I want you to do. Think about this. It's not a fraction. Make it a fraction. Okay? Okay. Now, unhappy exponent. Now, a happy exponent. We can't have a blank left on the top, so I need a 1. Okay? Next, do you see I have an unhappy exponent? I move it. Now it's a happy exponent. I have a blank. But often we don't see a 1 on the bottom of a fraction. We know better. That's how you would probably write it to simplify it. Okay, let's look at the next ones. Same thing here. It's not a fraction. Make it a fraction. Anytime you see a negative exponent, you have to make it a positive happy exponent. And you need that 1 on the top. Same thing here. Okay. The 2 is not movable. There's no negative exponent, so that stays. But the y has to stay or move, and I need that 1 on the top. And the last one for this one, do you see the 4 stays where it is? It does not have a negative exponent, so it stays where it is. The x we do have to move. When things go away, that means there's a 1 when everything is missing. But normally for this, you would just simplify it right down to that. Okay. Okay, so just a reminder, no negative exponents. So the rules only apply to the exponents that are negative. If this is the number -3, that number is -3. Is the exponent -3? No, that means -3 to the first power. That is as much as you can do to that one. Okay? Now for this one, I leave any positive exponents. I move the negative exponents. Oh, well, look, the x moves. The y also moves. Now again, for this one, usually we don't write that power of 1. That's not usually how we see it. We just kind of use it as a reference. Okay, for the third one over here, it's not a fraction, so I'm going to write it as a fraction just because it helps me remember if I need to move something to the denominator or the numerator, that's where it goes. The x has a positive power of 2. The y has a negative, that means move, and that's my answer. Okay, and last but not least, I'm going to move this one just down here so we can see it a little better. Okay, again, I'm going to put it over to 1. Now, -3 means -3 to the power of 1, or just -3. That stays. X has a negative exponent, so it moves. The y is really has a positive 1, so that y just stays on the top, and that's, or in the numerator, and that's where it shall remain. Okay, so hopefully you're getting good at these movement things. Make sure you're trying these. Pause at any time just to go back or to see if you want to try them on your own before you see the answers. Okay, same thing here now. Now, this is 3 to the power of -2. Is it a fraction? No. Is the exponent negative? Yes. So I make that negative exponent and means move it. Okay. Now, when I have numbers as bases, I want to do the math. So that means 3 squared is 9, 1 is just 1, so that would be 1/9. Okay. Now, this gets a little confusing because we have negatives, it feels like, all over the place. So here we go. This really means a negative over a negative. That 2 is not in parentheses at all. This x is not in parentheses, so that really means like a little -1 out front. So those cancel out to be positives. It's like saying a negative divided by a negative. So those cancel out to be positives, or they just cancel. Okay, the x squared is a positive 2. The 2 is like a little exponent of 1, but the y gets switched or moved to make it happy. And that's what you got. Okay, maybe try this one on your own if you want to. Pause it, okay, and then check it. Again, we have another one of these negative over a negative. That's a positive. That's just a 3. The x, make it a positive happy exponent. The y, make it a positive happy exponent. Okay, are you getting good at this? I hope so. Okay, now power to a power, basically. We're taking this power to this power. That means we multiply, don't add it, not the same basis. So that just means -3 times -2 is +6. We don't need to do anything. It's a positive exponent. We're good. Okay, let's think about this one. Now you take this -2 and distribute it, and that becomes -2 times -2, which is +4. -3 times -2 is +6. Woohoo! We don't have to end up moving anything because we end up with positive exponents. Now, this can become a little more interesting, isn't it? Now, remember, you can use the regrouping if needed. But the first thing I would look at within this parenthesis, can I cancel anything, reduce anything, numbers, things like that? Nope. So now I'm just going to distribute to start. So I'm going to start by saying this one and this -3 becomes 2 to the power of -3. X to the power of 2 to the power of -3 is -6. Y is -1 times -3, which is a +3. And now don't forget to do it in the denominator as well. That becomes z to the +6. Okay, now nothing I can do so far, but negative exponents I need to move because they're not happy yet. This 2 has a negative exponent, so I bring the 2 and the exponent becomes positive. That 2 is not a negative number. Be careful. The x also gets changed to the denominator. The y stays, and this z gets moved. Whoop, I'm kind of going in here. Now I see something I have to do. Do you see what you have to do? The y is good. The 2 to the third power is actually 8. And this is my final answer. Okay. Now remember, the main thing here, anything to the power of 0 is 1. 5 to the power of 0, a variable to the power of 0, all of this to the power of 0, even if I distribute it, that becomes that to the power of 0, that to the power of 0. This whole thing is 1. Now be careful. This is 4 to the first power, which is just 4. X to the power of 0 is 1. So this one would actually be 4 because it's not in parentheses like that one. This, if you really think about it, is -1 times x to the power of 0, which is 1. -1 times 1, that one would actually be -1. But this last one here, the power of 0 is 1 because the parentheses does change that. Just a reminder, we did this early. This means 2 times itself 4 times. So 2 times 2 times 2 times 2. This would be 16. 2 times 2 times 2. 2 times 2. 2. Anything to the power of 0 is 1. Now this means make this 2 go in the denominator. So that is really 1/2. We want to keep those as a fraction. And this one, oops, that's a 1, would actually be 1 over 2 squared, and that would be 1/4. So make that connection. We did that earlier as well, a little longer. Okay, try these on your own, and I will do them in just a minute. So pause it, try them on your own, and then come back. Okay, so I'm going to do these. Here we go. Think of this as over 1. The -3 stays because that's a big number coefficient out front. The x has a positive exponent. The y has a negative exponent. The z, and now everything is happy and all is good in the world. This is my final answer. First thing I know I'm really happy about right here, I see this y to the power of 0, that cancels to 1. So when I have to move anything, I know I have the x, that y goes away, that -4 needs to go in the front. That's how we write things algebraically. And this z has to go on the top. So that would be, there's really that power of 1 there, but we often don't see it. Okay, last but not least, distribute -5 to the power of -3, and that would be in parentheses, x to the power of -3, y to the power of +9. Remember, I'm multiplying. So now whenever I see a negative exponent, I have to move it to keep it happy. And move it to keep it happy. And leave the y to the 9th on the top. Now, I do have that -5. That's a number. I need to figure out what that is as an actual number. So in your calculator, you would use the parentheses, and that actually gives me -125. Now, you can put that 125 attached to the 5. You could also put it out front if you wanted to. That's both. You just can't put it in multiple places. Then things cancel out. So again, just a reminder of what we wanted to learn today. Did you learn these? So please take some time and do the practice worksheet along with today's learning check. Okay, have a great day. Ask questions if you need them.